I'm Ishan Sharma, Group Product Manager in Google Kubernetes Engine team, and I would like to speak to you about GKE and AI Hypercomputer. I have quite a few different topics to cover, but again, let's have a conversation. I want to keep this interactive. I do have a few demos that I'll talk through. One of those would be a live demo. So let's get right into it. So you all are familiar with Google Kubernetes Engine. I had spoken to you last year about it, so we have made some improvements since the last time and launched quite a few features at Google Cloud Next. I want to talk about the value proposition first, and this is sort of the pattern in which I will go through covering a variety of different content. The first part is industry-leading infrastructure. Now, my colleague Elias previously presented a little bit about that, and you will hear more about it later, so I won't go too deep into it, but I want to talk a little bit about GPUs, TPUs, and the foundation of running AI workloads on Google Kubernetes Engine. Second thing I'm going to talk about is training quickly at mega scale. Here we talk about the largest Kubernetes cluster scale, and we talk about how we can efficiently share resources using things like Q. Number 3 is where we're going to talk about serving and with a focus on lower cost and latency, and of course, ease of use. We'll then talk about accessing GPUs and TPUs in an economic manner, because that, again, comes down to total cost of ownership, which is very important to everyone. And the last thing is faster time to value. How can we make it easier for you to do all of this quicker? So that's where we're going to wrap up. So with that, let's start with the industry-leading infrastructure. My colleagues will cover this in more detail. All I want to say is this is the portfolio of accelerators, GPUs, TPUs. Of course, there's CPUs alongside this, if that suits the needs of your workload, especially for serving. But for training and serving really large models, you get all of those accelerator, all of the ones here, and any future ones on GKE on day one. So we are committed, we work internally to make sure that whatever accelerator Google Cloud announces is available on GKE on the first day, so you can get the best of it throughout. You've seen this in a previous presentation. Want to talk about Cluster Director for GKE. So just as a review, AI Hypercomputer is the entire stack. It's a reference architecture. It's a supercomputing system that's really distilled from a decade of Google working on AI and the expertise in AI. In fact, Vertex AI runs on AI Hypercomputer. So this is the same stack that we're internally using. Now, when we get into Cluster Director, the real thing is models are getting bigger and bigger. Previously, they were doubling every year. Now they're doubling every 6 months, right? And so when you think about that, the needs are higher and higher in terms of what the infrastructure can do. Your customers are deploying and managing larger and larger clusters of accelerators with compute, storage, networking, all of that put together. And all of these need to work as a single unit. And that's really where Cluster Director for GK comes into play. And let me talk a bit about what's unique about this. So for Cluster Director for GKE, it lets you deploy, scale, and manage AI-optimized GK clusters where physically co-located accelerators work together as a single unit, again, giving you high performance and ultra-low latency. Now, one of the things about Cluster Director for GKE is that you can orchestrate all of these new capabilities that I'm going to talk about using standard Kubernetes APIs and the ecosystem that's there. There's no new platform. It's just the new capabilities on really the platform that you already know and love, which is GKE, under the hood Kubernetes, right? So there's nothing new that you need to learn. It's all kubectl, it's all Kubernetes, it's all container workloads, right? So what are the benefits here? And that's really what this slide is about, which is what does Cluster Director provide from a GK perspective? So let's start the 6 things. We'll get through all of them. First thing is high performance. So this is really where you can run densely co-located accelerators as a single unit. Now these accelerators in the foundation, in the lower layer, come together, as we talked about in the previous session. You have machines that are physically co-located right next to each other. So either they're on the same rack and they're sharing NVLink domain, connected by NVLink, or they are across different racks, and then you're able to reduce the number of network hops that you need to do, thereby improving the overall efficiency of the system. Now, when you talk, the second thing is mega scale. So this is about, and I'll get into this in more detail, it's about running mega scale training jobs with the confidence that GKE, the GKE control plane, is not going to break a sweat. So GKE supports 65,000 nodes, which is the largest scale among managed Kubernetes providers. Third is topology-aware scheduling. Yes, you have all of these accelerators in the data center physically co-located close to each other, but they're not occupying the same space. That's just impossible, right? They are a little bit apart. So it's good to know what is here, what is next to it, what is one removed from it, what is beyond. So you need to know a bit about the topology, even though we have compactly placed them. What we do through GKE is and I'll show you in a little bit, we expose that information to our users so that they can use that information to schedule workloads in the most efficient way. And I'll show a demo of that in just a little bit. Ease of use. Now, setting all of this up is complicated. So we provide you with a variety of options depending on what you're trying to do and your skill set to be able to use all of this. And we'll talk about that. 360-degree observability, day two operations. You're running all of these. You want to know, why is my job not the most efficient? Or, hey, it's efficient. That's cool. Let me look at it. Right? Those are things we provide you out-of-the-box observability dashboards to let you do that. And finally, resiliency. We let you, if you have stragglers in if you have bad nodes in your deployment, we let you report right from GKE, report faulty nodes, replace with spare capacity if that's available.
Hi, Bart Jongens from Bitcoin. Question about, just to be sure, co-location for me is a data center that I can choose like Equinix or something like that. But for you, co-location means that it's your data center, but I can choose which GPUs are in which rack and so on for the best performance.
I'll explain what co-location from our perspective is, right? Yeah. So you are already choosing which region you want to run within. Yeah. Now, of course, you want all of this to be compact placed. When we say it's really a statement of compact placement. So within a data center, if you have accelerators on a rack here and accelerators on the rack on the other side of the data center, that's like a couple network hops, go through the data center network and get to that. You're sharing traffic with a bunch of other things as well. We don't want that. What we want is this one to be right next to it.
And that's your data center.
Yes.
Okay, but makes sense. That's clear. Then the second one, 65,000 nodes for a GKE cluster. Yes. A node, is that a bare metal server or is it still a VM somewhere, or I can pick a bare metal server as well?
A GKE node is a VM. Yeah. So it's a VM, and a VM can have multiple accelerators. Depends on the machine shape that you choose. For example, if you're choosing a H200 GPU or B200 in the 8 GPU configuration, each VM is going to have 8 accelerators in it, B200 or H200 accelerators, and that is one GKE node. Yeah. So that would be the expanse of it. So in this case, it would be 65,000 times 8, which is 500,000 accelerators. If you were able to find a data center with that many altogether, that would work. Yes.
Okay.
It's the upper bound of it.
Hi, Mitch with Futurum. You were talking about the size of large language models and getting much, much bigger. Some folks are kind of using VLLM to make it easier to integrate with models. Or is that something you're doing, or are you taking a different approach?
Yes, we are, and I'll actually show you a demo right on that subject. Okay. So hold that thought, and we can dive more into it. And that's awesome. So I mentioned about to the question that you just asked, right? About where are these located? So I've actually visually demonstrated that. You have a reservation. You reserved a bunch of capacity because you want to run a training job. Now this capacity, and here what you're seeing in the cartoon I have here, animated GIF, is each of those little tiny boxes in blue, those are let's say those are racks, right? And each rack has a bunch of accelerators or trays of that. And these are all, now this is not to scale, this is just for visual, but let's say there's a block of capacity with multiple racks that's in a data center. You are running a really large training job, so you have 4 blocks of capacity. All of these blocks are connected to each other to reduce network hops. When you go from one block to another, you might be going through the data center network, which would have other traffic on it. So ideally, you want to stay within a block, and most training jobs for our customers fit within a block. Now you have a lot of training jobs that you want to run. You have one hero, you have a couple other ones. You want to target block 3 because other blocks have some other jobs running on it, maybe some serving jobs, etc. You got a reservation. How do you tell GKE, I want to create a node pool targeting block number 3? We have enabled that right through our node pool create API. So it's very simple. Create a dense reservation. You can query the topology information. How do we expose it? You can query the compute reservations API. You get sort of the block information for a particular reservation. It comes in the format reservation name, block name, and then you create a GKE node pool on this block. How do you do that? Simply say reservation affinity is specific. I want to target a specific reservation. And then you just pass that whole string, reservation name and the block name. And you will create your GKE node pool on that particular block. In this case, it would be block 3. And of course, the rest of those are your same parameters that you use already when creating a GKE node pool. So again, we have worked hard to make sure that you're not having to leave the surface of GKE API as we integrate the cluster director for GKE features. Next feature that I had mentioned was viewing the topology information. Now, within that block, of course, there are many racks. You want to know which is on rack 1 and which is on rack 24. And you want to be able to run your job in a way so that you schedule it in a manner that you are not, you're reducing, when you do your all reduce operation, you're doing it very efficiently. So how do you do that? We have exposed the underlying, so previously this was difficult to get. You would have to figure out which GKE node you have. You would figure out which VM you're running with that node. You get the VM ID, you go and query GCE or talk to your account team, and then you get a list, and then you look at it, and then you run some Python scripts. It was complicated. What we have done is we have exposed this information as node labels, Kubernetes node labels, within GKE. So every GKE node that you create within this sort of dense reservation will have layers of topology information. The one you would be familiar with the most already is the 4th one, which is kubernetes.io hostname, which is just your node name. So that's the VM, that's the node, Kubernetes node. The rest are new. So we have host, which is the VM, which might, again, might have multiple GPUs within it, 8 GPUs, for example, for the AB200 or H200 machine shape. Subblock is actually a rack, so how many are put in a single rack. And then you have your reserved blocks. So within the block, they're connected with the top of the rack switches, and you can look at that topology. All of this is on every node within your cluster that's created in a dense reservation. So now the key thing is, because these are node labels, you can use Kubernetes concepts to go and do things with it, right? Simple Kubernetes concept for I want to node affinity, anti-affinity, I want to schedule here or not there. But what we do is one step better. What you can do, and this is an example of a deployment that I had, which talks about the block, which is sort of that first column there. They're all the same. They're within a block. I use block targeting. The sub-blocks, so they're split across, and I'm squinting here, they're split across 3 racks, I think, and then the hosts are all going to be different because those are different VMs. So this lets me do things with this. If you use Q, which is our scheduler, you can set preferred topology and required topology here. So what you can set within Q, and we have spoken about that previously, so I'm not going to go into too much detail about Q with a K. You can set your preferred topology, so you can prioritize within a particular given topology level, or you can do required topology. For example, I want to schedule this entire job, it's a small job, on a rack. So it will look in your entire node pool, it'll look for where is a rack that's empty that can take these many pods and schedule it on there. Put 1 pod per node, so it needs that many nodes that are free. It will schedule it there. But if it cannot, it will just wait, it will prioritize another job. For preferred, it's like, I would like this, but if it doesn't work, do the best effort you can. So all of this runs on a greedy algorithm, so it'll try and schedule it in a way that makes sense. And it's all openly available.
Okay. Lino Telera, and that's a good question. Are you implementing some kind of CRDs on GKE, or implementing some kind of custom commands that you can issue on Kubernetes?
For Q?
Yeah.
So for Q, you would have to install Q, and then which is open source. And then within Q, when you write your manifest for that, these are parameters that would go in there. And then they would interact with the GKE node labels automatically. So all you have to specify, among other things, there are other things in there, you'd have to specify which of these you would want to do.
Okay, gotcha.
So,
thank you.
Okay, next thing I spoke about is maintenance is important. Now, disruption handling, right? So when you're running a training job, all of a sudden the host, by host I mean the VM, the underlying hardware, goes into maintenance. Went into maintenance, and now your job is disrupted. So what can you do about it? What we have done is we have exposed upcoming maintenance that's scheduled through node labels in GKE. Now, having that, again, available as node labels in GKE lets you run node affinity, node anti-affinity, etc., to schedule your job. So here are some of the times. This is Unix epoch time. This is when the maintenance is scheduled. Let's say my maintenance is scheduled 3 weeks from now or 2 weeks from now. My job is 3 weeks long. I can't run that job. I would rather run it on nodes that have maintenance scheduled 4 weeks from now. I can do that. Examples are affinity, anti-affinity. You can avoid completely any nodes that have host maintenance scheduled, or you can schedule around that using logic from that particular way. The other thing is you can also trigger maintenance, not through some fancy APIs. All you need to do is supply a node label, perform maintenance equals true, and GKE will take care of it. We will cordon your node, we will evict your pods, we will respect pod disruption budget, we'll call the underlying GC API, we'll run the maintenance, and then your node is going to be back up and running. So it makes it very simple for you to manage your nodes at the GKE API level.
So, Ishan, on these node, okay, so I'm thinking, you're talking about rack level, physical topology for GKE nodes. Is a customer coming in and then contracting with you for a set number of racks that they're doing? So you guys are almost playing like a colo kind of thing situation here, or how is that working in terms of a contract situation with you all? Because somewhere along the lines, I'm like managing the looking at the logistics of this, because you guys are all about optimizing that entire cloud. And this is clearly, you can have stranded nodes sitting someplace else. So how is that working?
So all you need to give us is how many nodes do you need of that particular GPU? So how many GPUs do you need, right? So the typical request would come in, I need 512 accelerators, GPUs, in the A4 high GPU 8G configuration, which is a B200 in an 8G configuration. I need 512 of those. Give that to me. What we will do is and give that to me in a dense placed manner, which is through cluster, some of the stuff we discussed. We will give that to you. We will optimize that for you. You don't have to worry about racks. You don't have to do any of that. All you have to do, if you want to schedule a workload, is go here and say, I want to optimize all of this. And my job is going to use 100 of those. So within the 512 that I got, figure it out for me, and Q will do that for you.
So, and then let's take this to the next step, which is the screwiness the data does, right? And I'm going to want my data close to those GPUs. What are you guys doing to handle that? Because that network hopping there really can muck up the training.
So that's a little more complicated because there are different levels of data where you would have like, let's say you're doing a checkpoint, you would have different layers of where you want a checkpoint. So let's discuss that a bit more because of course, with the VM, there's storage that's available next to you, there are SSDs,
But if
all
I'm
of
using
those.
Lustre to pipeline into
Right.
you,
Right.
it's a different game.
We're going to
Yeah.
cover that in the next
You'll have to hold your thought there. So great.
framework,
services.
665. As part of that topology selection, is that including network connectivity? So making sure that those nodes have full network.
Yeah,
Not just
yeah, that's a whole, yes. So if you're within VM to within a rack, and then all of those, you're getting the full bandwidth, especially with our H200s, the A3 Ultras and the B200s, we are getting bandwidth, GPU to GPU bandwidth, inter node to be 3.2 terabits per second. That's one of the changes that we made. We're using CX7s underneath and the NVIDIA reference architecture, so that all helps.
And how large does that full bandwidth go? Up to a block?
That would be a great question to ask Dennis. I think he will cover that later today in the afternoon session because that's more on the infrastructure side. I'm running a little short on time, so what I'll do is I'll quickly cover this one, which is you can do the same thing with if you have identified a faulty host as a GKE node, you can just put the fault behavior as a reason, and it will again do everything, coordinate the node, evict the pods, call the GKE API, and then do all of that for you. And if there's capacity available, replace it. So that's really powerful. 65K nodes, we launched this at KubeCon last year, and this was basically, if you have a large cluster, be rest assured we will be able to run it. And Anthropic has given us a testimonial on that, and so is Character AI. I want to give you a quick demo about two things. So this is the GKE Inference Gateway. What this does is it's really helps. So there's high variability of LLM inference responses where load balancing, traditional load balancing techniques like round robin just don't do justice, right? So what we have launched is GKE Inference Gateway, which routes requests based on LLM model server metrics like KV cache, et cetera, and queue length. So let me give you some visuals. So what we have here is 6 replicas of VLLM model server serving an LLM, right? We ran a load test on this using ShareGPT publicly available data set. On the what you see in the chart here, the top is the KV cache utilization. What you see is that some models servers are saturated, while some are underutilized. So there is a bit of distribution there. What you see at the bottom is sort of when the model servers become saturated, the incoming requests, and that's the average queue size, those start to get queued. So there's that big spike up that happens when model servers are starting to hit that top rail and get saturated. So what happens when incoming requests get queued, the LLM responses are much slower. So vicious cycle that starts to happen. The chart at the bottom is the time to first token latency. So now, with GKE Inference Gateway, which is on the right side of the chart, what you can see is we've reduced that variability quite a bit. So everything is running very tight. And then what happens to your queue size and that queue size at the bottom? Very flat. You don't get those sort of spikes and queuing that happens when you're starting to saturate your utilization. So that's the general concept behind this. And this is real data, so it's not. This is something that you will observe if you run this. And then when incoming requests never queue, ultimately what matters is LLM responses are much faster. So your time to first token latency is much better. So so customers like that. One more thing I want to show you is GKE Inference Quick Start, and for that I will just very quickly go over to my other screen because I think this is really cool and I really want to show this to you, even though I might be running out of time. But so this is the GKE homepage on console.cloud.google.com. Go under AI/ML. Now let's say you want to deploy a model and you don't know, you have to figure out the underlying infrastructure. You might traditionally run benchmarks and all of that. Well, we have done the work for you and we have come up with the optimized infrastructure for these models. So let's hit deploy model. Now, some of these you will see are say the word optimize or labeled with optimize. Now, one of my favorite models here is Gemma 2 for reasons from Google. It has a bit of information on it. You can read through it, more like a model card. I hit deploy, nothing's going to happen. You'll be able to configure. Want to use it with Google Kubernetes Engine. I'm going to say Gemma 3 demo as my deployment name. Now, this is the cool part. So look at this. We have recommended by Google. I don't know, are you able to all see it? It's big enough?
Yeah.
Yeah, okay. So it's recommended by Google. And it tells me NVIDIA L-Force is what I'm looking. Okay, so that's the Gemma 2 2B instruction tuned. Now let me go to the Gemma 2 27B. And if you notice, it changed it to NVIDIA H100 80 GB, right? So we have run benchmarks and come up with what's the best type of accelerator, what's the best configuration. You can tune your maximum latency, and then essentially add in your Hugging Face access token, which I put in here, and then I have an autopilot cluster that I'll run it on, and I'll just hit deploy. But before I hit deploy, I want to show you something. You can hit View YAML, and you can just view the entire YAML, make any other changes you want to. So it's not just a UI thing. You can copy this, put it into your favorite editor, and then deploy it on your autopilot cluster, or just hit deploy, and we will start provisioning this for you on the existing autopilot cluster. So it'll start to generate that entire thing. So it makes it easier to run all of this based on the underlying infrastructure. Other things that I just want to talk about is this is the compute classes aspect of it. So let's say you're serving, you want to use Spot, you want to use a variety of different machines, you're optimizing for cost. You can set, I want to use A100s with Spot, but I want, or with reservation, if that's not available, run it with any reservation or fall back on Spot, etc. And that's their DWS dynamic workload schedule is another way to run your workloads. We have smaller machine shapes available. And then these are the last thing that I'll talk about, which is different ways of creating your clusters or deploying them. We have Cluster Toolkit, which we discussed at length previously. In the previous session, you can create GKE clusters with it. If you're looking for a Pythonic-like interface where you don't want to look at anything Kubernetes-like, XPK is something to check out. And then we also have a UI application. The UI application is again available. You can go through it and create, again, on the AI/ML page that I showed, you can deploy that. And I have a video here, but we can view that later. I'll share the slides with you. And these are the dashboard metrics. Out of the box, DCGM, TPU, and GPU. And with that, here are some key links to look at to learn more.